Hey everyone, and welcome. Today, we're cracking open the modern architect's toolbox. We're going to be talking about one of the most powerful ways to build systems that are not just scalable, but truly resilient: event-driven architecture. Think of this as your guide to building for the future. All right, let's just get right to it with a really important question. I want you to think about the systems you're working on right now. Are they actually built to handle what's coming just around the corner? Because the future isn't just about being up anymore. It's about being instantly responsive, globally available, and incredibly tough to break. And this is why that question matters so much. These right here, these are the exact points where old school architectures just break. You know the feeling. A massive traffic spike grinds everything to a halt, or teams can't ship features because they're all tangled up in dependencies. And the worst one, that dreaded cascading failure where one tiny service hiccup causes a total system meltdown. If any of this sounds familiar, stick around. So what's the answer? It's really a fundamental shift in how we think. Instead of services constantly asking each other, hey, do you have any updates for me? We move to a model where services simply announce, hey, this just happened. That's event-driven architecture in a nutshell. A producer service emits an event like order created, and any number of consumer services can react to it. The best part? The producer has no idea who's listening. That decoupling, that's the secret sauce. Okay, with that big idea in mind, let's get our hands dirty. We're going to pop open the architect's toolbox, which is filled with specific purpose-driven patterns. Each one of these is a tool designed to solve a very particular problem in this event-driven world. So let's grab our first one.
First up, we have the simplest and maybe the most common tool in the box: event notification. Its job is super straightforward. Just give other services a quick heads up that something important changed. It's like sending a quick text message instead of a long, detailed email.
And here's how it works. See, the order service just fires off this tiny little event, and all it contains is maybe the order ID. That's it. Then the inventory and notification services hear it. Now, if, and this is the key part, only if they need more details, they can go ask for them. This keeps your event messages small, your network traffic light, and your services beautifully independent. All right, let's look at our next tool, which kind of flips that last idea on its head. This is event carried state transfer, and it's what you use when you want to eliminate that follow-up call completely. The job here is to pack everything the consumer could possibly need right into the event itself. So this version of the order created event is way richer. It's got the order ID, the user ID, all the items, the price, the whole shebang. So why would you do this? Well, it all comes down to one thing: performance. The consumer gets this juicy event and can get to work immediately. No extra network hops, no waiting for another service to respond. It's all about speed. Okay, now this next tool, this one is a real game changer, especially for systems where audit trails and history are absolutely non-negotiable. With event sourcing, you stop thinking about the current state of your data as the source of truth. Instead, the sequence of events that built that state becomes your source of truth. Just look at this timeline. The state of an order isn't just one row in a database that you keep updating. No, it's the result of replaying these unchangeable facts. It was created, then it was paid for, and then it was shipped. This gives you a flawless audit trail. And even cooler, you can do something called time travel debugging, where you can replay events up to any point in the past to see exactly what the system looked like. It's amazing. Ready to level up and talk about performance at serious scale? Let's talk about CQRS. It stands for Command Query Responsibility Segregation, which is a mouthful, but the idea is simple. It recognizes that the way you write data into a system is often totally different from the way you need to read it out. So why on earth would you use the same model for both? CQRS literally splits your system into two paths. You've got the command side, which handles all the changes, the writes, and then emits events. It's all about consistency. Then you have the query side, which listens to those events and builds specialized, read-only views of the data. These read models are optimized for one thing and one thing only: blazing fast reads. This lets you scale your write traffic and your read traffic completely independently of each other. It's a huge deal for high-performance systems. So in this new world of microservices, you run into a classic problem. How do you manage a single business process that needs to touch 3, 4, or even 5 different services? The old way with distributed transactions is just slow and brittle. Well, the Saga Pattern is the modern event-driven answer. It is the tool for keeping your data consistent across services. Let's follow an order saga. The order created event kicks it all off.
The payment service hears that, does its thing, and then publishes payment completed. Then the inventory service hears that, reserves the items, and publishes inventory reserved. But what happens if something goes wrong? Say the inventory step fails. Well, it emits a failure event. And the payment service, which is listening, sees that failure and issues a compensating event like refund payment to undo what it did. It's a beautiful, fault-tolerant workflow with no database locks. All right, PubSub is probably the most fundamental pattern in our entire toolbox. Its job is incredibly simple, but unbelievably powerful. Let one service publish an event and allow any number of other services to subscribe and listen to it, all without the publisher ever knowing they exist. This is the absolute peak of decoupling. And you can see that power right here. One single order-created event goes out, instantly a whole symphony of activity kicks off. The email service sends a confirmation, the analytics service updates a dashboard, the fraud detection service runs a check, and the shipping service starts getting things ready. And tomorrow, if you want to add a new service that listens for orders, you can, without ever touching the original order service. That's true scalability. So far, we've mostly been talking about reacting to individual, discrete events. But what if the real value isn't in a single event, but in the patterns you can find across a whole river of them? Well, that is the job of event stream processing. It's all about analyzing data while it's in motion. Just picture it, a massive, high-velocity stream of events, maybe financial transactions or user clicks on a website. A stream processor can analyze that flow as it happens, looking for patterns, counting things over time windows, and transforming data on the fly. This is exactly how real-time fraud detection works. It's not looking at one transaction in isolation, it's spotting a suspicious pattern of transactions over the last 30 seconds and immediately raising an alarm. Okay, our last tool tackles what is, for many architects, an absolute nightmare scenario. What happens if your service saves some data to its database, but then it crashes before it can publish the event telling everyone else about it? Your entire system is now inconsistent. The Outbox pattern is the critical reliability tool that makes sure this can't happen. Here's how it gives you that rock-solid guarantee. When you save a new order, you do two things inside one single database transaction. First, you write to your orders table. Second, you write the event itself to a special Outbox table. Because it's one transaction, they both succeed or they both fail together. It's atomic. Then a separate little process comes along, safely reads from the Outbox, publishes the event, and then marks it as sent. Your data and your events can never get out of sync. So as you can see from this quick summary, there's no single best pattern. It's all about making smart trade-offs. You want maximum decoupling? Event notification is your friend, but you'll pay for it with an extra data fetch later. You absolutely need a perfect audit trail? Event sourcing is the tool for you, but be ready for some added complexity. Choosing the right tool from the toolbox means really understanding the job you need to do. And the best part is this isn't just theory. You have used systems built with these patterns every single day. That e-commerce site you love, it's using Saga's and the Outbox pattern to make sure your order is processed reliably. Your bank, it's using event sourcing and CQRS for bulletproof transaction histories. This stuff is out there in the wild, powering the modern world. So I'm going to leave you with a challenge. Go back and think about a system you work on. Find just one process that's slow, synchronous, and blocking, where one service calls another and just sits there waiting. Your mission is to redesign that flow to be event-driven. Pick one of the tools we talked about today, and, most importantly, be able to explain why it's the right one for that specific job. And that really brings us to the final thought. Now that you have this toolbox, you have the patterns and the language to build better, more resilient, more scalable systems. So the only real question left is this: what's the first process you are going to redesign? Thanks so much for tuning in.